Hey folks, welcome to the next video on the types of matrices. Before we solve some problems, you guys should understand some of the terms and the terminologies or some of the names on how matrices are addressed, so that in the exam when they ask you show that this matrix is a identity matrix or something like that, you'll be able to relate that. Not much of stuff here in this, it's pretty easy but very relevant video for you to really understand the problems. Okay, a quick and short video and then we can move on. All right, so some of the things we already covered, but let's have a quick recap. So the first thing is the order of a matrix, also called as dimension. What does it mean? Order of the matrix is nothing but how many number of rows the matrix has followed by the columns, right? The first will be the rows and second will be the columns over here, right? You write the rows first and the columns, right? Rows multiplied by columns. That's what the order of the matrix is. For example, if you see here, the rows are on this matrix, right? It's called as a 2 by 4 matrix because it has got two rows, and rows are nothing but you can think of something as which is in the direction of x-axis. This is the rows. Okay, so if you see here, this arrow is in the x-axis, this whole one row, right? And this whole part is another row. So two rows, that's what you have here. Number of rows first multiplied by, it's not multiplied, it's just a way of saying that it's like 2 by 4. It's not a multiplication, it's like 2 by 4, just a symbolic way of representing. And columns are anything that is in the y-axis, right? Y-axis kind of direction, if you remember, that's columns, right? So it has got 4 columns. If you see, everything is in the y direction, 1 2 3 4, and hence 4. So row followed by column, 2 by 4. So if anyone asks you what is the order of this matrix, you count the rows first, which is 2, and the columns 4, and then you say the order is 2 by 4. That's it. This is not multiplication, this is like by. Similarly, like some of the self-explanatory examples here, this matrix has 2 rows and 3 columns, right? So whatever is in the x direction, there are 2 rows. This is row 1 and this is row 2 and 3 columns, like they pointed out. So the order of the matrix is 2 by 3. First you put the row followed by the column, right? Stuff like that. Same here. So that's what the order of the matrix is. So you should understand that. Okay, the next thing is, this is the recap that we already done over here in terms of matrix multiplication. Whenever you're trying to multiply two matrices, say U and M over here, there's one matrix and there's another matrix. So let's say you have two matrices and you're multiplying it that. The first check is whether the multiplication is possible. Is it even defined, right? That we tried, right? And what does that mean? You write the order of each of this matrix. So the left one is, this is like say U and this is like M. Okay, M is the right matrix. So the order of the matrix is 3 rows and 2 columns, for example. So 3 rows, 1 2 3, and 2 columns. So it's like that, right? For example, I can say 1 2 3, sorry, 2 columns, right? So let's say I take this 1 2 3 4 5 6. So now in the direction of x-axis, this one has 3 rows, and the direction of y-axis, this one has got 2 columns, C1 and C2, right? And if I have another matrix which I need to multiply, right, like this, which has got 2 rows, so let's say 7 8 and 3 columns, right, 9 and 10 11 and 12. So I've got 2 rows and 3 columns here. So in this case, is a multiplication possible? The way to check that is, like I said, the number of columns on the left matrix should be equal to the number of rows on the right matrix. Number of columns on the left matrix should be equal to the number of rows on the right matrix, right? Something like that. Or if you put the orders together, these two numbers should be equal. Then the multiplication is possible or defined, and that's the whole thing that we have explained it here using the verbiage. I'm not going to go through that, you can read, it's very self-explanatory. And the order of the matrix, once you multiply whatever is the net result of this U and M, whatever is the order of the matrix, what will be the final number of rows and columns in that matrix, that will be determined and derived by the remaining two numbers on the two matrices. In this case, the number of rows and the number of columns here, right? So the final matrix will have, it will be a 3 by 3, meaning that it will have 3 rows, 1 2 3 4, 5, 6, 7, 8, 9. So it has got 3 rows and it has got 3 columns. So the final order of the matrix, if the rule number 1 is satisfied, which means the multiplication is possible, then the final matrix, the net matrix post multiplication or post transformation, will have an order which will be determined by these two numbers, the first and the last, or the number of rows on the left matrix and the number of columns on the right matrix. Hope that's not confusing. Okay, for deriving whether the multiplication is possible, you take the column and the rows, the column on the first matrix and the row on the second matrix. But to determine the number of the order of the final matrix, the net result, how many rows and columns you have, you do the opposite. You take the rows of the first matrix, or you take the rows on the left matrix multiplied by the columns of the right matrix. Okay, pretty simple. Okay, now what are different types of matrices? Some of the matrices have the names and some have examples, but we'll mix and match and see what's going on. What is a row matrix? And a lot of these things are pretty much this kind of define or literally mean what the name says. Row matrix. This matrix will not will have only one row. That's it, one row. You see here in this case, the order of the matrix is 1 row and 3 columns. This matrix will have only one row. Okay, what is a column matrix? Also called as vector matrix. If you remember, a lot of examples we took, we were assuming a vector, right, in any direction with A and B coordinates. If I put them in the matrix notation, it will be represented like this. It's also called as a vector matrix, but it doesn't matter. The names are same. What is a column matrix? Is exactly the opposite of row matrix. It will have only one column. That's it. And the rows could be anything. In this case, it has got 3 rows, right? So what is the order of the matrix? I write the rows first, 3 rows, 3 by 1. This is the order of this matrix, right? This is the order of the matrix. I always write the rows first. In this case, it's 1 by 3, 1 row by 3 columns. That's what it is. Now, what is a zero matrix or a null matrix? As the name implies, does not matter how many rows or how many columns. All the data elements within the matrix is 0 or are 0, right? Here, like for example, here is the example and here is an example. In this case, it's a 3 row and 5 column, like there are 3 rows and 5 columns, but all the elements are 0. This is a zero matrix. And over here, it has got 3 rows and 2 columns, 3 rows and 2 columns, but all the elements are 0. So regardless of the order of the matrix or how many rows or columns the matrix has, if all the data elements, every single one of them is 0, then it's called as a zero matrix. So we have covered this, we have covered this, we have covered this, we have covered this. Okay, now let's take the next example. And we have covered this also. This is a row matrix. See, it has got only one row. We have covered this also. This is column matrix. So we have covered all of this. Okay, what else is pending? Okay, let's jump here. Square matrix. Whenever the number of rows and the number of columns are equal, whether it's a 2 by 2 or a 3 by 3 or 4 by 4, the rows and the columns should be equal, giving it a shape of a square. Then it's called as a square matrix. What is a rectangular matrix? If the number of rows and the columns are not the same, like the square matrix. So if it's not a square matrix, then it's going to be a rectangular matrix. Okay, that's what it is. Okay, now we have covered all of that. Now let's come here back here. Diagonal matrix, right? What is diagonal matrix? A diagonal matrix is a matrix where we have some non-zero numbers across the diagonal, which starts from the top left to right here, right? The diagonal of this matrix, the way I draw it, the elements falling on that diagonal are not 0, but the rest of the data elements, excluding the ones on the diagonal, are 0. Then it means it's a diagonal matrix. Okay. Scalar matrix, we already spoken about that in the previous two videos in what is scalar matrix. Whenever you use this kind of matrix, which is a special case of a diagonal matrix, right, where the diagonal elements are not 0 and are same. Here in this case it was A, B, C, but in this case it's A, and A, and rest of the data elements are 0. And the net effect of the scalar matrix is, if I use a scalar matrix on my left, this is a scalar matrix, and this is my, let's say, any input matrix that I have or input vector I have. So the net effect of this transformation, what happens is this scalar matrix, based on what is the diagonal element, right? This whole matrix will be scaled up or scaled down by that much. So it will become bigger or smaller if you remember the clock or the alphabet M. That's what is called a scalar matrix. All the numbers on the diagonal are same, and rest of the elements are 0. Unit matrix. Unit matrix is a special type of scalar matrix and diagonal matrix where the elements on the top left and the bottom right of the diagonal are same. The rest of the elements are 0, and the value of the diagonal elements are 1. And if it's not 1, it's more than 1, then it becomes scalar matrix, but it will have the same effect. So unit matrix is also called as identity matrix here. So we have covered this also, where the diagonal elements are 1. So what happens if you use unit matrix, which is a special type of scalar matrix? It will not do anything. It will just, because anything multiplied by 1 is the same in terms of the number system. So this will give you the same effect. This and this will give the same effect. If you try to, instead of this scalar matrix, if you try to say use unit matrix here and multiply it with an input matrix, whatever, nothing will change. This input matrix will be the same over here. Like anything multiplied by 1, right? Whatever effect, anything multiplied by 1 is the same, right? Whatever the number, nothing changes. So that's the concept of unit matrix. This input matrix on the right will exactly be the same as output because you're multiplying it by unit matrix, which is again a special type of scalar and diagonal matrix. So we have covered this also. This is also done. This is good. The last two metrics are upper triangular and lower triangular. As the name implies, upper triangular is, if you see here, it kind of gives a shape of an upper triangle. So the diagonal and the elements on the top of the diagonal are non-zero, whereas this part, the lower side, is 0. So that means the numbers on across the diagonal on the upper side of the diagonal are not 0. So it gives the shape of a triangle. If you see this, if you combine this, is a triangle, right? So that's called as upper triangle matrix. And the lower triangle matrix is the exact opposite. You draw the diagonal, anything below the diagonal where this gets shaped. So the triangle shape is formed using the non-zero elements across the diagonal and below the diagonal, and that's what they give the shape. And anything above the diagonal, this element, this part is 0. So those are like lower triangular matrix. So that's all pretty much the types of matrices, and you'll see in the next set when we talk about questions and answers, and we'll be using the terminologies. We'll do a quick recap. But in textbooks, there are multiple pages explaining that. I don't think you need to really remember that and get overwhelmed. Just remember the concepts. The names will follow through as you practice more, and it will be automatically be in your head. You don't have to like mug up everything right away. Okay, that's a quick wrap up on this video. Hope you guys got this clear. Order, matrix multiplication, and types of matrices. More coming up. Stay tuned. I'll see you in next video, folks. Thank you.